Hello, my name is Tomas Horyl, and today I will be talking about building the digital twin with Mikrotik CHR, Containerlab, and Ansible. My colleagues were enough brave to convince me to do a live demo, so please bear with me if something goes wrong. um, Hopefully not. Something about me. So last almost 20 years I've been doing networking design and development, also Linux system administration, and intermittently also computer networking infrastructure maintenance. Now I work in Narrowin, which is Swiss University spin-off. We do network and security designs, consulting, and we develop our own product, Lightweight Network Explorer. Yeah. So today we want to talk about digital twin. This is something that we use daily, especially because of the development. We need to test certain features. We need to, we cannot always afford to implement things in live network. So for that, we need to build some testing environment. So at the beginning, there is always some design, then we test it, deploy the configuration, and then potentially also validate the configuration. For the planning and validation, there are many tools that you can use. We use our own, as I already mentioned, the Lightweight Network Explorer, but I would like to talk today about the right side, which is testing and configuration deployment. For testing, we will use Containerlab. I don't know if you have heard about it. It's very nice, lightweight testing environment. And for configuration deployment, we use Ansible. If I manage, so just that you imagine about what you can achieve with this setup. This is, for example, one of our testing environments that we use. This is completely deployed Containerlab and using Ansible. But today we will do much simpler topology, not something like that. So what is Containerlab? It's a tool for orchestrating and managing container-based network operating systems. It can also run or support virtual machine-based operating systems. It provides connectivity among these hosts, especially using Linux network namespaces. And it's built on top of containers, which are almost everywhere these days. It supports Docker as well as Podman. So for us, it's perfect as a testing environment. It covers a lot of vendors. If you look at the page of Containerlab, there are many, many vendors that are supported. Obviously, you need some sort of either virtual machine or container, but we will see that later, how to do it for Mikrotik, because obviously now we are focusing on Mikrotik. And one of the biggest benefits for us is that the topology definition is text-based. It's in YAML, and therefore it's perfectly scriptable. Such that you can imagine how the topology file looks like. It's very easy setup just with two nodes and one link between them. With kind, you only say what kind of operating system it's running there. So for Mikrotik rootOS, it's Mikrotik ROS. If you had, I don't know, Cisco, there will be Cisco IOL, for example. Then you specify image, which is the image that should be ran inside. And then you define what interfaces you connect and how we connect them. Then there are just a bunch of commands that you can use, but today we will just use deploy, which is obviously you start all the containers and then just start running. Then destroy stops them, and you also have, during the startup, Containerlab automatically updates etc hosts and SSH config. So you can use names to connect to all those containers. Obviously, since it's running in Docker, you can also use docker exec to enter the container itself. I will just start. So now the funny part starts. Oh, first success. So now I started the environment. We will make use of that later, but you can see that it was very easy, no problem. For those who don't like really CLI, I don't know how many of you don't like CLI, but there is also VS Code extension, which is, I have to say that even though I'm the CLI guy, I appreciate what they did with VS Code, because especially for myself, there is TopoViewer, where you can see the topology like visually, not just in text-based format. And also it integrates with packet capture. We will see how to attach Wireshark or TCP dump, also from the CLI as well as from another nice, very nice tool. But the possibility to attach Wireshark is also in VS Code extension. Another thing that is very nice, Containerlab supports link impairments. So you can actually introduce delay, packet loss, things like that, and simulate real world scenario. So as I mentioned, not all, most of the network operating systems are containers. Luckily, there is a solution. It's this VRNetLab, which is fork of the original VRNetLab repo. And what this basically does is that it packages the virtual machine inside container and provides some additional functionality such that you can connect all those containers together using the Linux namespaces. Just caveat from my side, because I already made that mistake, you have to do that with this fork. The upstream repo will not be compatible with Containerlab. So now we have the topology, it's running, but we need to somehow deploy the configuration. That's fun if you do it once, because I always liked deploying configuration, I don't know why. But if you're testing something, that's really time-consuming, error-prone, and very, very inefficient. For this, we have Ansible, and it's good because there are already predefined configuration templates, or you can predefine them. You deploy the configuration just with one command, and can be installed anywhere where Python runs, so even Windows. Now something about how Ansible handles network operating systems. The best scenario is that Python is available on the operating system, which is very rare, but there are cases. It's perfect because then Python copies modules onto the operating system and it runs them locally, executes them locally. And then there are plenty of other network operating systems where Python is not available. So we have to deal with that some other way. In case of Mikrotik, there are two modules, command and API. Command module is nice in a sense that it just executes the commands as you use them normally on the router board. The problem is that it was meant to be for human, not for machines. So especially when you get back the output, you have to somehow parse it, and it's not very easy with command. Then there is another module, which is API module, and that's perfect for machine processing. Another benefit is that it's faster for batch processing or batch operations. But there is one drawback: it's not available for all CLI features. So, but they are kind of complementing. So far we were able to do anything we wanted using both of these modules. We know that Ansible is kind of overwhelming, or can seem overwhelming when you start and look at it at the first time. So we decided to actually publish our solution that we use. We developed that solution with Sycor, which is Swiss. It's a supercomputing center at University of Basel. And it's free for use. So if you decide to use it, give us a star on GitHub. That would help us. You can just clone the repository, install requirements. Anybody who ever tried to install something in Python knows how to do that. And you can start using that. A colleague of mine actually created a very nice thing. He put everything into dev containers. So you don't have to even install anything on your system, because you can just clone the repository, and using devpod, you can run the dev container on your machine. And you can play, decide if you like it, if you don't like it. It's just very easy. Even better, it's also available in GitHub code spaces, so you don't have to even clone it. You can just run it on GitHub, and that's it. Okay, Ansible inventory. So this is the way how you define, how you tell Ansible how to reach the devices. Also in inventory, there is, you define your credentials, so username, password, or SSH key. And in inventory, there are also groups. Groups put together devices with some common parameters, let's say. Just to demonstrate it, I created a screenshot. The basic group is all, where all the devices belong. Then you can have group Mikrotik. Then you can have Mikrotik switches. And from there you can just branch down, and you can see that, for example, you have very similar variables for Mikrotik switches, and for Mikrotik 12-port switches, obviously you have only 12 interfaces. So this is the group that where you define how many interfaces you want to configure. Okay, let's try first example with Ansible, and we will use the command module because we don't actually need to do anything specific. I will talk about it later, why we need API, but command for now is perfect. The only thing that you need is to define the host name or IP address, which we already have in inventory. And then you need to specify where the configuration should be stored. So if it's not, okay. Here I will just run this command and explain what is in there. So I'm running playbook. I forgot to mention what is playbook. Playbook is basically recipe, or you specify what tasks you want to run on the host. And I used, if I put this command here, I used switch -- limit, which tells Ansible, don't run this command on all devices, but on the group that I told you. So in that case, this is Mikrotik S3N. So now you can see the benefit of having groups, because you can tell, okay, deploy this configuration in specific region or on specific devices. And now if we look here, see that we have the backup. It's quite empty because there is no configuration yet. Now let's try something more. It's not that much more complex, but let's change hostname on all these devices. For this, we would like to use something that provides idempotency. What is idempotency? It's just very basic concept that tells you no matter how many times you run this command, the output will be always the same. It's repeatable and predictable, and idempotency is important in cases when you don't want to add configuration, because you have a specified state and you want this device to be in that state. You don't want to pile up configuration on something that was already on the device. So let's try now. Here I would like to also demonstrate how you can, so now we know that we are limiting that to the group Mikrotik S3N, and with tags, each task in our playbook is assigned a tag, which says, okay, I want to run only tasks with tag hostname. So now I want to only configure the hostname. And check and diff are actually doing, check is dry run, and diff show me the differences that will be deployed if I run it without these switches. So let's have a look. And you can see that there is a change on all three devices. And the change is that the name will be changed from SWACC1 to CLab S3N. So then if we review all the changes and we are satisfied with what we see, we can just deploy it without this check and diff. It's changed, and now to demonstrate the idempotency, if I run it again, there is no other change because it was already changed and the state that we wanted is already in the configuration. And last example, it's interfaces. Interfaces in a sense that now we also make use of these group variables. So just that you can imagine what that means. Let's say here, I define that 12-port switch obviously has only 12 interfaces. And these groups we have for 24-port switch for any other device or a group that you can imagine. So let's have a look. What would happen if we run this command? That's okay. It looks like fine. Okay, so let's run it. And again, we can just demonstrate that if I run it twice, no other change because the change was already done. That was it. Now we can just do the full deployment, which means that if let's do, so I know that there is this Linux system running, so I can connect to it. And I know that on the other end there is 10.1.1.2. Obviously now, without the configuration, it's unreachable. So let's deploy the configuration. And let's see if we get the connectivity after finishing this playbook. Here you can see that it's going through all the tasks that we specified in the playbook. It's executing them and changing the configuration on all switches just with one command. And okay, so that went well. And here we can see, okay, now we have the connectivity. There is one nice tool that I would like to tell you about, and it's Wireshark. So what this tool does is that it actually visualizes all Linux namespaces, network namespaces on your machine or on the machine where Wireshark is running. And it's nice because you can, here, you can, for example, say, okay, I would like to see the traffic on this interface. And this small icon with fin next to it, you can guess what it's used for. It launches Wireshark, and hopefully, because it's running from battery, so that is the effect of live demonstration. But we can first verify. I can show you with a lightweight solution. So here I'm using Linux network namespaces, and I'm attaching TCP dump to the interface of the uplink interface of the switch. And you can see that it's getting the packets that are getting through it. Okay, and actually I don't know what interface. Maybe I just attach wrong. So Linux 1, 2, because I attached management interface. So let's try this one. Now, I realized that I didn't show you the topology. It's so if I go here and do so this is the topology. Linux 1 is the one that we are connected to. Then there is stream switch, another switch, then the third switch, and then Linux 2. Okay. So now hopefully I finally found, okay, the right interface. So now we saw all the functions of the system itself and how can we leverage that to transform our real network into digital twin and vice versa. So first we have to start with the inventory. We have to specify where are all those devices that we want to reach. Then just for testing, we can do backups because backups are always good. And then start with small steps. Limit your ground by using limit switch and tags. That way you specify the group that you want to execute the command on. And start definitely with dry runs because you don't want to deploy the configuration and not know what will happen. So start with dry runs. Here is just for the reference one of the examples. And since we already have, let's say, the source of truth in place, why not leverage that for our workflows, our daily workflows? We can start with zero-touch provisioning, just deploy very basic configuration such that the device is reachable by Ansible, and then use Ansible to deploy the configuration into all these devices. On the group level, we most likely already find a group where to put our device into because most likely you already have that group in your network. And if you need to specify variables that belongs to just this one device, you can do that on host level. Then obviously we can do configuration backups if you regular configuration backups if you don't have already some other system that you use for backing up configuration. And we also plan to add support for ad hoc firmware upgrades. And to conclude, from my experience, it's always good to do test before deploy because I've already experienced quite nasty things happening in production network. So I'm really glad that something like Containerlab now exists, that I can first try my design in safe environment and then just when I confirm that what I got is what I wanted, I can deploy it in the network. That therefore limit any financial damages, downtime, user experience degradation, and stuff like that. Then we have centralized network source of truth, which is beneficial, especially when you need to share data between teams. I remember from my past, we already had a lot of copies in different departments and everybody was working with different data. So it's definitely good practice to have just one copy of the data in your network. And full cycle automation, it's something maybe originally in software development, but I think that we can also benefit from having this in network environment, that we can just test and deploy the configuration, and then maybe if we are brave enough, we can also automate it with validation of what we have in our network, and do this continuous, testing of requirements, and if are still matching those requirements that were at the very beginning. I'm almost precise with the time. So any questions?
No questions? So thank you, Thomas, for your beautiful presentation.
So just for you, here is the GitHub repo. You can try it and see if you like it or not. Thank you.
Thank you.